Next question. Imagine you have 100,000 files, each file containing 100,000 records on 100,000 distributed machines that you need to sort. What sorting algorithm would be the most efficient? So you need to understand here the scale that makes it impossible to solve with a normal sorting algorithm. Okay, there are 100,000 files, each of the file is having 100,000 records that amount to 10 billion records in total. They are spread across 100,000 machines. No single machine can hold all that data. No single machine can sort all that data. The first thing that I notice about this problem is the scale. 10 billion records across 100,000 machines. No single machine can hold all of that data and no single machine can sort it. So a standard sorting algorithm such as quicksort or merge sort applied to the full data set is simply not an option. The problem is too large for that approach. The right mental model here is not which sorting algorithm, but how do I sort the data that is distributed across so many machines? The answer is a distributed sorting strategy. And the most well-known and proven approach for exactly this kind of a problem of distributed sorting strategy is MapReduce, specifically an external merge sort implemented across distributed nodes. Here is how I would approach it. The first phase is local sorting. Each of the 100,000 machines already has its own files and records. The first step is to sort the data on each machine independently. Since each machine has 100,000 records, that is entirely manageable. A standard merge sort or quick sort on each machine to do it locally works perfectly well at that scale. So after this phase is completed, every machine holds its own data in sorted order. The second phase is partitioning. Now I need to merge all of this sorted data globally. To do that efficiently across 100,000 machines, I use something called as range partitioning. I sample a small portion of the data from across all machines to understand the overall distribution of values. Based on that sample, I divide the value range into partitions. Say values from A to M go to one group of machines, values from N to Z go to another group. Each machine then sends its record to the correct destination machine based on which partition that record belongs to. The third phase is distributed merge. Each destination machine now receives sorted chunks from many source machines, all containing values within the same range. It performs a merge of these sorted chunks, which is efficient because each chunk is already sorted. This is the merge step of merge sort applied at the distributed level. So basically what we are doing, we have the chunks of sorted data. We are performing a merge of these sorted chunks in the third phase, which is called as the distributed merge. Now after this phase, each destination machine holds a fully sorted partition of the global data set. And since the partitions are range based and non-overlapping, if you read from the machines in order, the entire data set is globally sorted. This approach is essentially how Google's MapReduce works, and it is also how systems such as Apache Hadoop and Apache Spark handle sorting at massive scale. The specific algorithm inside each phase is merge sort because merge sort is stable, predictable, and works extremely well for external sorting where data moves between storage and memory in chunks. The time complexity is big O of n log n per machine for the local sort plus the network transfer cost for the shuffle phase. The bottleneck in practice is almost always network bandwidth during the shuffle. So in a real system, I would also think about data compression during transfer and co-locating machines that need to talk to each other. If I had to name the algorithm in one phrase, it is distributed external merge sort implemented through a MapReduce pattern. In short, local sort on each machine first, then range partition across machines, then distributed merge. The algorithm is external merge sort applied at a distributed scale, which is exactly what MapReduce implements. So in the local sort, each machine sorts its own data. It is cheap, parallel, no network cost. Then sampling is done. Sample data to find value distribution ensures even partitioning. Then we perform the range partition, sends record to correct destination machine, groups same range data together. Then we perform distributed merge. Each machine merges sorted chunks it receives. Efficient because chunks are pre-sorted. Result is each machine holds one globally sorted partition. Read machines in order to get the full sorted data set. I'll see you in the next audio.